let's continue our discussion with the fundamental theorem of algebra. And this time, let's look at a quartic equation. I already have example 1 here, 10x to the 4th plus x to the 3rd plus 7x squared plus x minus 3 equal to 0. We're going to first find our p-value, just like we did with a cubic. So we're going to take the constant term and find the factors of it. So we have plus or minus 1 and plus or minus 3. This time, if we look at the q factors, which is the leading coefficient factors, we have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. In order to have a rational possible answer, we're going to take our p's and divide them by q's. So in this case, if I take 1 and divide it by each of these terms, I get some interesting things happen. I have 1 divided by 1, which is 1. 1 divided by 2, I get plus or minus 1/2. 1 divided by 5 gives me plus or minus 1/5, and plus or minus 1/10. Likewise, if I take my 3 and divide it by my q factors, I get plus or minus 3, plus or minus 3/2, plus or minus 3/5, and plus or minus 3/10. Notice how these problems could get quite interesting quite quickly. Notice we only have 2 integer values out of 8 possible different factors. And when you multiply that by your plus or minus, you have twice as many. So let's go ahead and start working on this. I'm going to arbitrarily pick 1/2. So if I take 1/2 and I'm going to plug in my 10, my 1, 7, 1, negative 3, bring down my 10, I have 5, 6, 3, 10, 5, 6, 3, 0. Oh, look at that. On my first try, I got a 0 by just using the 1/2. So I know that x equals 1/2 is one of my solutions. So looking at my remainder, I have 10x to the 3rd plus 6x squared plus 10x plus 6 equal to 0. Now I can look at this cubic instead of that quartic up at the top. Well, if we notice 10, 6, 10, and 6, we can factor out a 2. And what this is going to do is reduce the number of factors that I can possibly have for my solutions. So now I'm looking at 5x to the 3rd plus 3x squared plus 5x plus 3 equal to 0. Remember, there's not a variable with that 2 out there. We can simply divide it over, and 0 divided by anything is 0. So we really are just getting rid of that constant term. So now if I look at this cubic, I can start over with my p-values. Remember, my p-values are the plus or minus 1, plus or minus 3, the factors of the constant term. My q-values are going to be the factors of the leading coefficient. So I get plus or minus 1 and plus or minus 5. Notice the nice thing with this is that the number of p-values and q-values has reduced from our quartic. So we don't have as many to try. So let's take our p's and divide them by q. We end up with plus or minus 1, plus or minus 3, plus or minus 1/5, and plus or minus 3/5. Now I'm going to test each of these possible rational roots into my cubic function. I don't need to worry about my quartic because I've already got one solution and I'm working with just this cubic equation. So I can go ahead and try another arbitrary number. In this case, let's try negative 3/5 by chance. Let's see what happens. It looks like a fun number. So I have my 5, my 3, my 5, and my 3 again. Bringing down my 5, I have negative 3/5 times 5, which is negative 3. Adding those down, I get 0. 0 times negative 3/5 is 0. Bring down my 5. Negative 3/5 times 5 is -3. And look at that. Would you look at that? That is absolutely amazing. 2 times I picked strange numbers and they both worked for me. All right, so we know then that x equals -3/5 is going to be a possible solution as well. I knew the answers, really. I didn't just do it on my own. So my equation is 5x squared plus 5 equals 0 as my remaining polynomial. I'm going to go ahead and take 5x squared plus 5 equals 0. Well, I can go ahead and factor out a 5. So I get x squared plus 1 equal to 0. Now I'm left with x squared plus 1 equals 0, since I don't have a variable with the 5. So that goes away. And I can use the square root method to solve x squared plus 1 equals 0. So here x squared equals -1, so x equals plus or minus I, as I take the square root of both sides. So now I have my 4 solutions. X equals plus or minus 1, x equals plus or minus 3/5, and x equals 1/2. So recapping our quartic, it works very similar to our cubic. We're going to find our p's and q's, p divided by q, and then find one that gives us a remainder of 0. Once we do that, we're going to write our cubic function, factor if we can, find our p's and q's, and p divided by q, find another 0 by again plugging in each of these numbers until we get one that's a factor, or a 0. Once we get down to a quadratic, then we can use our quadratic formula. We can factor, or our square root method, however you wish to solve it. And that's basically our quartic equations using the fundamental theorem of algebra.